Thank you everyone for coming here today. I am Yuto, a summer intern at Mercari search team. And today I am excited to share with you one of the projects that we worked on over the summer, and that is precision tuning. So let me begin by giving you the outline. And first of all, I will go through the overview of Mercari search system so that all of you understand what I will be talking about. And then I will explain the problem that we had with the search system and our solution to the problem, which is precision tuning. And finally, I will share the results and insights we gained from carrying out the projects. So this is what you get when you search with a keyword in Mercari. And by default, we use a ranking called newest first. And that is a ranking based on the combination of freshness and relevance and spam. So we promote items that are new and relevant, and we demote items that spam or what we consider to be duplicates. And this works for most of the keywords, and that is why we have this newest first as the default search system. But for some specific keywords, this newest first fails to return a good search result. And I'll show an example. So here is a search result for the keyword iPad device. And this is an example of a keyword with a problem. And as you can see, there's so many noise. So when users search with the keyword iPad device, they want the iPad, and they don't want accessories such as battery or charger or iPad case. But here, most of the items are all those noise. And we call this situation of too much noise low precision. And this is an urgent problem that needed to be fixed, not only because it creates lost opportunity for users, but also because it was a source of user frustration. And according to user surveys, many of them listed this low precision as the main reason for frustration when using Mercari. But it was not an easy problem to fix for two difficulties. So the first one is that not all keywords are the same. So there's different types of search in Mercari. And in Mercari, we can roughly divide keyword searches into two types. And one is informational search, and the other is transactional search. So the informational search is when users search with a vague or broad meaning keywords with nothing specific in mind. So, and they just go through the search results just like reading a magazine or scrolling through the Instagram feed. And in this case, users want to explore the search result, and they are waiting to encounter some items that are attractive to them. So we should return a search result with a variety of items. But the other one, the transactional search, users search with keyword with some specific product that they want to purchase. And in this case, we have to return a search result with that specific item, because that's what the user is looking for. And having these different types of search means that uniform measures does not work. And we actually tried improving precision for all of the keyword in Mercari, and the result turned out to be unsuccessful. And the second difficulty, this one is actually specific to Mercari by the nature of C2C marketplace. So most of the items of Mercari are user-generated items, which means they're one of a kind and they have no stock. So when somebody purchases that item, the item is sold out and nobody else can buy it anymore. And also in Mercari, the sellers often edit the item in an attempt to make the item sell faster. So they may change the item by retaking the picture or changing the title or description. And this means that all of the items have a short lifespan and also are constantly changing. And because of this, it is hard for us to learn an item's relevancy to a keyword because we cannot use the collective knowledge. Before we gain enough collective knowledge, the item is going to either be unavailable or edited. So to decide on the best approach to solve this problem of low precision, we measure the magnitude of the problem, and that is how many keywords there are to be fixed. So the keywords that we want to fix are the keywords that are popular and are transactional and has low action rate, because they are the keywords that are low precision. So we find keywords that are popular by just looking at the search count. High search count means popular. And finding transactional keywords are rather hard, but we can do it by looking at the length or the specificity of the keyword. So when the keyword is longer and more specific, it is more likely to be a transactional keyword. And also, we sometimes use the chronological user behavior, and that is what other keywords they search with after searching with the specific keywords. And that's how we find keywords that are transactional. And the last one, finding keywords that has low action rate, we just look at the metrics that we use, such as click-through rate and sell-through rate. And they just mean how many items users click or purchase from their search results. And given these difficulties and situations, we decided to solve the problem of low precision by per keyword basis precision tuning. And that is, for each keyword, we do three things. So first, we determine the user intent. That is, we figure out what users want from the search keyword. And second, we do the query rewriting. And this is the process of actually improving the precision. And finally, we implement that query rewriting into the production environment as we start running the A/B testing. So now I go through the details of each three steps. So the first step, determining the user intent. To determine user intent, we look into the items that users either click or purchase. So sticking to the same example of the keyword iPad device, when users search for iPad device, they click or purchase iPads. But it turns out the parameter, the category that each keywords are in actually reflects, actually separates the correct items from the noise. So as you can see up here, the items that users click or purchase, which is the items that are iPads, are in the category tablets. And the noise that are batteries or chargers, they're in a different categories. And there's no overlap. So in this case, we can use the parameter of category tablet as a key parameter that reflects the user intent. And of course, it is not always the case that the correct items and the noise are in a different categories. But in those cases, we look at price range or brand. And some of them, in most cases, works to differentiate the correct items from the noise. And the second process is query rewriting. And here, we just boost the key parameters that we found in the previous step of determining user intent. So as I mentioned, we boost either category, price range, or brand. And they each are efficient at eliminating different kind of noise. So the category, boosting category often works for eliminating noise that are accessories. So that's like battery for the iPad. And boosting price range often works for eliminating 4 parts items. And for some keywords, the search result has too much 4 parts item, and that makes it harder for the buyers to actually find a functioning item. So the price range actually works more often than you expect. And for the last one, the brand, boosting brand, it works for eliminating the noise that are generic products or off-brand substitutes. And finally, the third step of implementation and A/B testing. We implement the query rewriting, which we did in the previous step, into the production environment, and also run the A/B testing. And this process would normally take time because you have to write the code and you have to wait for the code review. But we managed to make this process go faster by making this the management tool. So with this tool, we only have to specify 3 things. So we just have to specify the target keywords that we want to fix, and the key parameters that we want to boost, and how much we want to boost. And with those three things specified, this management tool is going to take care of the rest. They're going to check for errors in the input, and they're going to, if there's no error, they're just going to implement the query rewriting into the production environment. And they start the A/B testing at the same time as well. So with this tool, we managed to run these 3 steps of precision tuning in less than a day, which would otherwise take 2 or 3 days. And now I'm ready to show you the results for the same keyword, iPad device. So as you can see, the search result got cleaner in the newer search result. And we got it by boosting the key parameter, that is, as I mentioned, tablets. And we also saw an improvement in action rate. That is, users click more items from the search result, and they purchase more items from the search result. And we did the same thing for the other roughly 100 keywords that had a low precision problem. And roughly 90% of the times it worked, so we got basically the same result. Cleaner search result and improved action rate. But some of you might be wondering, what's the 10% that didn't work? And that 10% is actually the keywords where we couldn't determine the user intent. And that brings us to the next slide. That is insights that we gained from running this project. So the first, it is still hard to measure user intent. So I mentioned that we measure user intent by looking into the items that users click or purchase. But when the search result has so many clickbaits, items that are clickbaits, this approach doesn't work. Because the clicks definitely does not reflect what users want because of the clickbaits. And also purchases, because there are too few of the purchases, it is not enough to have any statistical meaning. So for the search result with many clickbaits, that's the 10% that we couldn't fix. But that is not the end of the day. So now we're running different projects to gather more information so that we can understand the user intent better. And to introduce some of the projects that we already started, one of them is exclusion keywords, which allows users to specify keywords that they want to exclude from the search result. And by introducing this function, we can see which keyword have what kind of noise. And also we are introducing new search logs so that we can get a better understanding of user behaviors. And to recap, I talked about per keyword precision tuning, which is a quick and effective solution to low precision keywords. And also, it was made even quicker by our semi-automation tool. And this time we did it for 100 keywords. And we can probably do it for 200 keywords, but it would not be efficient to do it for thousands of keywords. And that is okay, that's why the insights that we gained matters. Because now we're applying those insights that we gained from running this project into more longer-term solution to optimize search results, such as learning to rank. And by reflecting those insights that we gained from this quick solution, we are improving our long-term solution to the bigger problem of optimizing search results. And I think in Mercari, we are always running different projects on different time spans. So for the same problem, we'll be running a solution that'll be quick and effective, and other solutions that takes more time, but more scalable. And they're both necessary, because the quick ones allows us to be flexible, and the longer-term ones allow us to scale. So running different projects with different time spans is what helps us create a better user experience. And if you're interested in other projects by search team, I recommend you to stick around to visit the talks by other members of the search team today, later today in the track A. Thank you very much, and I hope you have a great day.